right, so now let's graph y equals negative 2 sine 3x over 1 period. All right, so let's find, first of all, the amplitude. So amplitude is always positive, so it's going to be the absolute value of negative 2, or 2. And then there's also a reflection over the x-axis. We can take care of both the amplitude change and the reflection by simply multiplying all our y values by negative 2. But if you were asked the amplitude is actually 2, not negative 2. And then to find the period, we take 2 pi and divide by b. b is the coefficient in front of x, so b is 3, which means the period is 2 pi thirds. All right, so first of all, let's fill in our x and y values for sine. Of course, our quad angles, 0, pi halves, pi, 3 pi halves, and 2 pi. And the y values that go with it, all right, so sine is 0 at 0 radians, and then it's 1 at pi halves, and 0 at pi, and negative 1 at 3 pi halves, and back around again, it's going to be 0 at 2 pi. All right, so now the period change will affect x, so it goes in this box here. All right, and to find our values, we're going to take the period and divide by 4. And those are the values that go in that box there. So the period is 2 pi thirds. If we divide by 4, that's the same as multiplying by 1/4. All right, so that would be 2 pi twelfths, or we can reduce that. All right, you can reduce that 2 and the 4. 2 divided by 2 is 1. 4 divided by 2 is 2, which would give us pi 6. So that means we're going to start at 0 and count by pi 6. All right, so maybe I'll just change colors. 0, and then 1 pi 6, and 2 pi 6, which is the same as pi thirds, and 3 pi 6, which is the same as pi halves, and then 4 pi 6, which is the same as 2 pi thirds. And so, whoops, sorry. And so notice this value here matches this value up here. And I'm going to fix the board. Sorry, I hit the extended page. There we go. All right, so we have our new x values. So this right here is the new x. All right, and to find the y values, we're just going to take our current y values and multiply by the amplitude times, oops, it's not how you spell amplitude, amplitude times the, along with the reflection there. So instead of multiplying by 2, we're going to multiply by negative 2. All right, so 0 times negative 2 would give us 0, and 1 times negative 2 is, oops, I'm saying negative 2, but I didn't write negative 2. 1 times negative 2 would be a negative 2. There we go. And then, of course, 0 times negative 2 is 0. And negative 1 times negative 2 would be a positive 2. And 0 times negative 2 is 0. All right, so our new coordinates are, so that's our new x, and this is our new y. So we have 0, 0, and pi 6, negative 2. And pi thirds 0, and pi halves 2, and 2 pi thirds 0, And we'll go ahead and graph those. Just so we don't drive ourselves crazy, let's label every line pi 6. All right, so pi 6, pi thirds, or 2 pi 6, which is pi thirds, 3 pi 6, which is pi halves, 4 pi 6, which is 2 pi thirds. All right, and of course, we could also go the other direction, and then it would just be negative. All right, so let's go ahead and graph. Oh, and let's label this too. So that's -2, and that's 2. Get a little crowded on there. All right, so we'll graph a point 0, 0. All right, so we're just graphing one period here. We're going to graph the point pi 6, -2, pi thirds 0, pi halves 2, and 2 pi thirds 0. So our graph is vertically stretched by a factor of 2. It is horizontally compressed because instead of taking 2 pi, it's only taking us 2 pi thirds to go through the cycle. It is also reflected across the x-axis. And there we go. Let's just add in domain, which is all real numbers, and range. Our graph is oscillating between -2 and 2. We're going to do one more on this video, and this one is going to include what's called so we have a horizontal shift, and when we're dealing with trig functions, we call that a phase shift. So a phase shift is just shifting right and left. So the graph of y equals a sine bx minus c is obtained by horizontally shifting the graph. And I'm going to show you 2 ways that you can do it. All right, so you can read up there. Just know it's called a phase shift. So if I say phase shift, all right, that just means a horizontal shift, or shifting right over shifting left. Doesn't have quite the same meaning with trig functions as it, or at least especially sine and cosine, but it's with trig functions as it does other functions, because other functions we would just shift our whole graph over, right or left. In this case, though, because our graph keeps doing the same thing, all right, it's just getting to certain points at different times. So that's why we call it a phase shift. All right, so here's the 2 ways. Way number 1 is to simply, I'm going to do way number 1, I'm going to do this one first. All right, so here's choice 1. Choice 1 is you can factor out b. All right, so if b is not in the parentheses and it is not attached to x, then you would skip this part and we'd go right to the ending here. But let us say that it is not factored out. So if it is not factored out, you simply divide both terms by b. All right, so if I factor out b, I have y equals a sine, so b is going to be outside the parentheses. Bx divided by b is just going to give me x, and c divided by b would be c divided by b. Okay. So this represents the phase shift. Just like it would in any other function if we're shifting horizontally. All right, so if we see x plus, it's shifting left. If we see x minus, it's shifting right. So that means that x minus c over b means we're shifting right. So squeeze it in here. C divided by b units. Let me move that up because I'm not sure how well it captures the bottom of the board, especially on the Nearpod. There we go. All right, and so if we see x plus, there we go. If we see x plus c divided by b means we are shifting left c divided by b units. So this is one way, and this is the way I usually do it. All right, I'll probably do it both ways on the notes so they could just see both ways. It doesn't really matter which way, but I tend to use number 1. Now let's look at number 2. All right? It works just as well. It's just slightly different. Rather than factoring it out, we're just going to set what's in the parentheses equal to 0 to find out what our shift is, right? Because it's what's in the parentheses, that's our shift, right? But that's the C is only our shift once the B is factored out. But we can accomplish the same thing by simply setting this equal to 0. All right, so we have bx minus c equals 0. Add c to both sides. So bx equals c, and then divide both sides by b. So here, x equals c over b is our phase shift. If c over b is a positive number, it's a shifting to the right. Because if we wanted to move it back to the other side, right, so it was with the x, we would have to subtract, right? So it would be x minus c over b, the same thing as we have over on the right-hand side of the board. So if you have x equals cb and cb, oh, I meant to put it greater than 0, and cb is greater than 0, which is the same as x minus cb, that would be shifting right. If you have x equals c over b, actually I don't have to write it again, and c over b is less than 0, then it shifts left. And there we go. All right? So let's see that in action in the next graph. And by the way, if I go too fast, you have the ability to pause me. All right? And you also have the ability to ask me questions in class. All right, here's the next one. All right, and I'm going to do it both ways as soon as I move my recording screen. So we are going to graph one period, and we're going to identify all of these important things here. All right, so we have the graph of y equals 4 sine 2x minus 2 pi thirds, all in parentheses there. And we want to first find the amplitude, the period, the phase shift. Fill out our table, and then we'll graph. All right, so amplitude is that coefficient in front of sine, and it's the absolute value, actually, of that coefficient. But if it's positive, it's the exact same value. So the amplitude is 4. The period, you take 2 pi and divide by b. Whether it's factored out or not, b is the coefficient on x, so b is 2. So that would give us 2 pi divided by 2, which is just pi. All right, let's pause for a moment and fill in the x, the period change, the y, and the amplitude change. Right, and so we notice we have a box left over. This is for the phase shift, right? Because phase is shifting right and left, it affects x. So our x's, of course, are our quad angles: 0, pi halves, pi, 3 pi halves, and 2 pi. To find the values for the period, we take the period, which is pi, and divide by 4. So we're going to start at 0 and count by pi fourths. So because our important values happen 1/4 of the way through the cycle, right? You can just think of your quad angles, right? 1/4 of the way. So 0, and then count by pi fourths. So our next important thing happens at pi fourths, and then the next important thing happens at pi halves, and then at 3 pi fourths. And then notice that we have now gone through the whole cycle because, or one period of our graph, because that last value there matches the period. And I forgot to fill in the y values that go with those x values. Of course, that there's 0, 1, 0, -1, and 0. Right, so we're not done with x. But before we do that, let's take care of finishing off y, because we've already figured out the amplitude. The amplitude is 4. So that means that we're going to take all our y values and multiply by 4. So 0 times 4 is 0. 1 times 4 is 4. 0 times 4 is 0. Negative 1 times 4 is negative 4. And 0 times 4 is 0. Right? So our graph is vertically stretched by that amplitude change. It's horizontally compressed because we're going through the cycle faster. And it is also shifted. Let's find out how it's shifted. All right, so we're going to find our phase shift, and we can do it one of two ways. We can factor out b, or we can solve for x, and they're both fine. Right? So if I factor out b, I'm going to divide everything by 2. Well, divide these two terms by 2. All right, so that would give us, and I'm just going to do that over here, y equals 4 sine, the 2 comes out. 2x divided by 2, that's easy. Of course it's going to be x, right? So, because you're factoring out b, of course what's going to be left over is just the x. Right, so now you need to divide the 2 pi thirds by 4. And you might say, well, I don't know how to do that. Of course you do. You just multiply by a fourth. Right? So if dividing by a fraction is the same as multiplying by the reciprocal. So that would be 2 pi twelfths, or before we even multiply those together, we could reduce the 2 and the 4. That would be 1 and 2. So that would be pi 6. So that means our equation is y equals 4 sine 2, and then in parentheses, x minus pi 6. All right? So we can simply see our phase shift from, I will highlight it so you can see it. Okay? We can simply see our phase shift just from what's left in the parentheses, right? That's our phase shift right there. And that would be pi 6 to the right. Right? Or we can solve for x. Right? So if we solve for x, we have 2x minus 2 pi thirds equals 0. Let's see if I can squeeze it in. I'm going to put it over here so I don't get in too much of the way of the graph. So then we would add 2 pi thirds to both sides. And let me write that a little nicer. All right, so 2x minus 2 pi thirds equals 0. Add 2 pi thirds to both sides. So we have 2x equals 2 pi thirds. And then to get rid of the 2, it's kind of hard to divide a fraction by 2, right? It's much easier to just multiply by half. So we'll multiply both sides by half. So now this is x. And then this would be 2 pi. Oh, wait, no, I did that right. Yeah, that's right. X would be 2. Why do I have an extra 2? Did I make a silly little error? Let me make sure I didn't write anything down wrong. X equals, no, that's fine. All right, let's look on the other side. I factored out a 2. Oh, I'm sorry. All right, we have a little boo-boo. It's okay, we'll fix it. I accidentally, when I was looking up, wrote the 4 down instead of the 2. I want this value right here. You see where it's like moving? I want that value, the b, right? We're factoring out b, 2 pi thirds divided by 2. So that would be 2 pi thirds times 1/2. That would, and we could cancel out the 2's, and that is pi thirds. So if you're doing it on a giant whiteboard and you have to look way up, to see your numbers, it's not a bad idea to do it twice. Because if you make a mistake on one, chances are you won't make the same mistake on the other time. All right, pi thirds, excuse me. We're factoring out a 2, so I would divide 2 pi thirds by 2. not by 4. All right. But either way, my phase shift is the same, not this, but this, pi thirds to the right. All right, over here, this is greater than 0, so it's to the right. Notice I have x minus, well, let's fix it up there. X minus, oh, perfect, comes right out. I have x minus pi thirds, all right, that's pi thirds to the right. There we go, all good. I caught it, so it's no big deal. All right, so there we go. Let's fill in our phase shift. Now, for the phase shift, you're simply going to add it. Right? For the period change, you start at 0. Right? That one value doesn't move. You're just going through the cycle faster, but you're still going to go through 0, 0. The phase shift is you're just going to take your graph and shift it all to the right in this case. So if we're shifting to the right, we're going to add pi thirds. So to every one of these values here, we're going to add pi thirds. So 0 plus pi thirds would give us pi thirds. Pi fourths plus pi thirds. Oh, isn't that a lovely number to add together? All right, so pi fourths, I'm just going to do it off to the side here. Pi fourths is the same as, so if 4 and 3, the only number they have in the smallest multiple they have in common is 12. So I could change pi fourths by multiplying the numerator and denominator by 3, so that would be 3 pi 12. So 3 pi 12s and pi fourths are the same thing. So 3 pi 12s plus, all right, so pi thirds is the same, so 3 times 4 is 12, so this would be 4 pi 12s. So that is the same as 7 pi 12s. Let's see how many of these other ones. All right, so now 2 and 3, their least common multiple is 6. So pi halves is the same as 3 pi 6. And pi thirds, right, so I have to multiply by 2. So 2 pi 6. So this would be 5 pi 6. And 3 pi fourths plus pi thirds. All right, so 4 times 3 is 12. 3 times 3 is 9. So 9 pi 12s plus, of course, 4 pi 12s is a third. We did that earlier. Plus 4 pi 12s, right, the same as over here. That would give us 13 pi 12s. And then pi plus pi thirds. All right, well, we can just make that thirds. So 3 pi thirds plus pi thirds will give us 4 pi thirds. So you may have to do some work off to the side if they don't have common denominators. I knew that was going to happen when I hit that extended page. Here, we'll do it right here. We don't need that much extended page. All right, so equals 4 pi thirds. All right, so looking at our numbers, all right, it's nice to keep the same scale from graph to graph so you can see how they're different. But come on, we need to make sure we can graph these things. So why don't we just, we'll label our graph by 6. That won't be too bad. We'll label it by 6. Normally I label each one a half, but we've got 12ths in there. We can deal with a 12th, but if we label it by a half, we're going to have to do a lot of approximating. All right, so let's make sure our graph is labeled. So our graph actually fits on here. Let's make each one of these worth 2, all right? Because look at our points. We're going to need a 4 in there. Let's go ahead and write our points, and then we'll complete the graph. And that's the worst looking 4 ever. There we go. All right, so our points are And so this is our new x right here, our phase shift, because we have shifted our graph. So pi thirds 0 is our first point. 7 pi 12ths 4. And 5 pi 6 0. And 13 pi 12ths negative 4. And 4 pi thirds 0. All right, so there's our points. Let's go ahead and graph. All right, so, and where we're going to put domain and range, nobody knows. All right, so let's label it. So each one of these is going to be a 6th. All right, so we're not stretching it out too much. I don't think I can fit it with pi. I could if I made each one a 12th, but that's a lot of stretching. So pi 6, pi thirds, so pi 6, 2 pi 6, 3 pi 6 is pi halves, 4 pi 6 is 2 pi thirds, and then 5 pi 6, we got to keep going, and then 6 pi 6, which is pi, and then 7 pi 6, which is enough. We'll just go one more. 8 pi 6, which is 2 pi thirds. All right, so we stretched out the graph a little bit because if we look back over here, all right, I think we had 2 pi thirds only took up 4 lines. So we've stretched the graph a little bit because we did that, but we took up 8 spaces instead. All right, so the graph isn't taking 8 times as long to go through the sequence. And in fact, it's taking a little longer because it's pi as opposed to 2 pi thirds. Right? But we had to adjust our graph so we could actually reasonably graph our points. All right, so let's go ahead and graph pi thirds 0. All right, so pi thirds is going to be right here. So notice you can really see the shift when you only graph one period. If you graph more, it kind of gets blended in. But you can see that we have shifted over pi thirds because instead of 0, 0, we have pi thirds 0. All right, and then 7 pi, oh, I'm sorry, I'm looking at my points here. We have to make it all the way to 4 pi thirds, and I only graphed 2 pi thirds. Oh my. I guess I forgot how far we came. Pi plus a third, yeah, that's 4 pi thirds. Oh, I'm sorry. So I will warn you not to in class not to number your graph until afterwards. We are going to have to get more values on here. So instead, each says we got to get 4 pi thirds on here, and a 6th is just not going to work. Instead, let's see, so if I do, I should 1 6, 1 6, 2 6, that should work. Let me renumber that. Hold on. 1 6, 2 6, which is pi thirds. Oh, maybe I didn't see how far I went. No. So then this would be, hang on, this would be pi halves, and then this would be 4 pi 6 is 2 pi thirds. I think I had something, oh no, it'll fit. What was I saying? Maybe I didn't look very carefully. Ignore me. So 2 pi thirds, and then that's the same as 4 pi 6, 5 pi 6. We only had to make it to 4 pi thirds. I don't know what I was looking at. I think it fits. Doesn't it fit? And then 6 pi 6, which is pi, and then 7 pi 6, and then 8 pi 6, which is 4 pi thirds. I must have written down something wrong. I don't know, or I looked at it wrong. But this is 4 pi thirds. Okay, we're fine. We're fine. We can fit. Phew. I really didn't want to have to estimate any more than that. All right, let's finish this off. All right, so pi thirds 0. And 7 pi 12ths 4. Right? You might think, where is that? All right, well, at 12th, let's see. So we've got 4. This one's a third. Let's put these ones on here. Those are the two obvious ones. All right, so now 5 pi 6 is right here. All right, so now where does 7 pi 12ths go? Well, halfway in between those. So if you get some that are tricky and you can't figure out where to put it, put the obvious ones in and then look, okay, this has to be between these two, right? Halfway between. So halfway between is right here. So that is going to be at 4. And this is going to be at -4. And now we can connect and we have our graph. So now you can really see the phase shift. All right, our graph is starting in a new location. I kind of missed my point there, but it's okay. And then let's do the domain and range. So nothing changes the domain, all real numbers, and the range, we're oscillating between -4 and 4. Sorry about the graph there. I guess I just looked at my numbers and I thought it said something different and we didn't fit the 4 pi thirds in. But then when I renumbered, I realized, oh no, we're good. And that's the end of the graph and that's the end of my video. Thanks for watching. Bye for now.